Hello everyone. In this video, we will talk about the Mohr circle in two cases, like for both tensile and unequal cases. So you can see a bar here, and in this bar, you have got sigma 1 and sigma 2, which are tensile stresses and they are unequal. So this is a plane which is in theta degree angle. Okay, this theta degree angle is the angle in which this plane is in this bar. Okay, so on this plane, if you want to find the sigma and if you want to find the tangential stress, if you want to find the angle of the resultant stress, that is sigma r, so you can use these formulas as I have written here. You can use these formulas if you have the values of sigma 1, sigma 2, theta, and you can also use the graphical representation, which is also known as Mohr circle. Okay, this is a very easy method. I am going to explain it to you so that you can understand it properly, and you can also use it in your real life as well as in your exam point of view. So we have got this one case where both the stresses are tensile and unequal, right? So you can also have this case where one stress is tensile while the other is compressive. So you can see that sigma 1 is tensile and sigma 2 is compressive, as it is compressing this bar. So we want to talk about both of them. So at first, let me talk about the case where both of the stresses are tensile and unequal. Okay, so to make it more easy, let me take some values to make it more easier to understand. So let's assume that sigma 1 here, which is a tensile stress, so it is 120 Newton per millimeter square, suppose. And you have got sigma 2 is your 60 Newton per millimeter square, and this theta is the angle uh, with the minor stress axis. Now, what do I mean about this? So suppose sigma 2 is less than that of sigma 1. So in this case, you can see that sigma 2 is uh, smaller than the sigma 1 tensile stress. So in this case, the axis of this sigma 2 is the minor stress axis, while the axis of sigma 1 is the major stress axis. So this angle is given with the minor stress axis, you can see from here. So this is your 30-degree angle, which is given in the exam, suppose. So now I want to assume something. So let 1 centimeter is equals to 10 Newton per millimeter square, 10 Newton per millimeter square. Okay, so I'm assuming it. So that means sigma 1 will be equals to 120 over 10, 120 over 10, that is 12 centimeter, and your sigma 1 will be equal to 60 divided by 10, that is 6 centimeter. Okay, so now I want to draw them here. Okay, I want to draw them here. So sigma 1 is 12 centimeter. So now let me assume that I have got a 12 centimeter line from, okay, let me see, I need to make it centimeter. Okay, so I want to make a sketch. So where we were, actually sigma 1 is the value, that is 6 centimeter. Sorry, this is sigma 2. This is sigma 2 and sigma 1 is your 12 centimeter, right? So you will take a point, that is A, in your notebook, in your exam paper, or in your practice book. So this is a point A, and on this from this point I will draw a 12 centimeter line. I will draw a 12 centimeter line. Okay, so now I can draw a 12 centimeter line very easily in my software. So you know, this is your 12 centimeter line. So I am making it 12. So yes, so I have got a 12 centimeter line. Then what you will do, you will name, okay, let us forget about naming, or no, let us give the name, as we can give it from here. Okay, so suppose this point here, this point is B. Okay, capital B. Okay, so name this B, and after that what you are going to do is you will draw this 6 centimeter line from that point A. You will draw a 6 centimeter line from that point A. So for that, sorry, yeah, I'm going to draw a 6 centimeter line. So very easily you can draw it very easily, right? So I will just name it 6. So from this, the distance from this point is 6 centimeter, right? So what you have done so far, you have taken a line 12 centimeter from point A, and then you have named this point B, and then you have also marked a line 6 centimeter from the point A. Okay, after that what you are required to do, take a very close look at this point. The radius of the Mohr circle is sigma 1 minus sigma 2 by 2, and it is to be drawn from the point somewhere. Okay, so from point, let me name this point as well. This point is your C. Okay, this is your point C. Okay, I have marked this point C. So this point is your C. Okay, after that you can see that from in between C and B is going to be the radius of that circle you are going to draw right now. So what is going to be the C, the CB is going to be the diameter for the circle that you are going to draw. Okay, pardon me for my mistake. So CB is going to be the diameter of that circle. So what is going to be the radius? The radius is simply 12 minus 6 by 2, that is 3. Okay, 3 from this point, right? So I am going to mark a 3 centimeter line from this. Okay, you will do it. What you will do is you will mark a 3 centimeter line. Okay, let me just measure it 3, as I don't have the scale right now. So this is the 3 centimeter line from this point. Okay, so from this point now you are going to draw a circle. Okay, see, yes, it's completely aligning. The radius of the circle now is 3. Okay, so I have drawn a circle that is of radius 3. Okay, so now what you are required to do is very simple and easy. Now take your ruler and mark a point from here to here. Okay, draw a line from here to here. Now, what is the angle between this line and this line? This line and this line. What is the angle? The angle is going to be 2 theta. Okay, so suppose the angle you are given is theta equal to 30 degree. So your angle here there is going to be 2 theta. So that is going to be 2 into 30. That is your 60 degree. Okay, so 60 degree is going to be the angle. So now I can give the angle. This point and this point, the angle is 60 degrees. So 60 degrees is my angle. So I have given the angle 60 degree. Okay. Okay, my angle is ready. Now simply draw a line from this point to this point. This should be horizontal. This should be vertical. Okay, you have drawn a line from this point to this point. Then you can you can draw a line from this point to this point. Sorry, I'm sorry for that. So you can draw a line from this point to this point, and you can also draw a line from this point to this point. Let's name this point. The name of this point, let me give it. Okay, so yeah, now it's fine. So the name of this point is E. Okay, this point you can see this point. My mouse cursor is on. This is your E point. All right. So this is your E point. This is B point. This is C point. And let's name this point O. Okay. At this point, the name of this point is O. Okay. So you have also got the name for that point as well. Okay, so the name of this point is going to be O. Now you can do one thing, that just measure this length. Okay, this length you can see. You just measure this length. This is 2.60. So okay, I am not going to modify it. This length is your tangential stress. Okay, you can see that I have found the length. Let's name this point E. So this is your tangential stress. Sigma t is equals to 2.60 centimeter. It is in centimeter. So I have assumed a relation that 1 centimeter is equals to 10 Newton per millimeter square, right? 10 Newton per millimeter square. So in this case, my result is 2.60 into 1 centimeter was equal to 10 Newton per millimeter square. So my result is going to be this. Okay, sigma t is going to be this amount of Newton per millimeter square. And what is the value of sigma n, or the normal stress? This is to be measured from this point to this point. Let me mark it from this point to this point. This is your Okay, so this is 10.50. So this is your measurement for the normal stress, 10.50 centimeter. So we are not required to find the stress value in centimeter. This is just for the graphical representation. You will need to 10.50 into 10. You will need to multiply 10 in order to get the result in millimeter, 10 Newton per millimeter square. So this is your value for the normal stress. Now you can understand that what is the value for the resultant stress. Okay, so this is your value for the resultant stress, the value of this AE. AE is equals to your, okay, AE, that is also the sigma R, and that is going to be 10.82 into 10 Newton per millimeter square. So if you just multiply 10 with that, then you will get the resultant stress as well. So now what you need to find, suppose this was your 60-degree angle now. So this angle, you will see this angle is 30 degree. This angle is almost 29.99. That means this is your 30-degree angle. So if this is 2 theta, then this is going to be theta. So according to the, geometric laws, if you apply, you will find it. This is 60 degrees. So you can see that this is 29.99. That means 30 degree. So the angle that you will find here, it is your angle of the, this is all your phi. This is your phi. 13.89 degree, you can see here, 13.89. This is your phi. So phi, that is, which is the angle of the resultant. This is your 13.89 degree. We can find it by using the D, your geometric equipment. If you use that, you will find this angle, right? Because you won't be able to find it just by using the computer, using a software. So you'll need that. So okay, so you'll find the phi. We have found the resultant stress. We have found the normal stress. We have also found the tangential stress. So in the next video, we will find the Mohr circle. I mean the, sigma and sigma t phi in case of a tensile and the in case of a tensile and a compressive stress. Okay, so till then, take care and goodbye.